Okay, number 127, you have the set consisting of, actually on your document, it's the set consisting of P and Q, then the set consisting of P, Q, and R. However, just PQ, I chose a different type of number. I just chose to use 2 numbers, then 3 numbers. And it should be very clear to you that it's easy to transfer what I'm doing here to the sets where you have P, Q, and R. Okay, so subsets. Okay, first of all, you have the empty set. Then you have the set consisting of 2 and the set consisting of 3. Okay, any other subsets? Well, yeah, you have the set itself, the set consisting of 2 and 3. Okay, now subsets of 2, 3, 4. Okay, I'm going to list these subsets, and the empty set I'm going to list this way, 2 braces. For reasons it'll become clear, and I'm leaving myself a little room in these sets. And then I'm going to list them again. Leaving myself room in case I want to add anything to any of these sets. Okay? Well, again, I've just listed all the sets I had, all the subsets of the set 2, 3. Okay? Is there anything I could add to any of these sets? Well, yeah, I've got a new element. I've got 4. So I could add the element 4 to each of these 4 sets. And I choose to add it to the second row of my listing. I'll leave the first row the same. So, I've got extra space here, but I didn't use it. So the set is just what it was before. The extra space doesn't constitute an extra element, so the elements of these sets are exactly the same as the elements of these sets. Each of these sets has the same elements. This is a subset of this, this is a subset of this. This is a subset of this, this is a subset of this, and so on. These sets are certainly equal to these sets. Okay, but these sets aren't. None of these sets are equal to these sets because each of these sets contains 4. So none of these sets can be equal to any of these sets because none of these sets do contain 4. So we have 4 new sets. Now it's clear from the way we listed this that we've doubled the number of sets. So if we went to 2, 3, 4, 5, adding another element to this set, then we could list all 8 of these subsets, and then we could list them again. In the second row, we could add the element 5 to every one, and we would have, again, doubled the number of subsets. So that the number of subsets doubles every time a new element is added. Now, if we have 2 elements in the subset, actually, let's just start out with the empty set, which has 0 elements. How many subsets would the empty set have? Well, it has 1, which is just the empty set. Okay, what about the set consisting of the number 2? Okay, it has 1 element. How many subsets does it have? Well, it has 2. has the empty set and itself. Okay, what about the set 2, 3? Has 2 elements. It has 4 subsets, as we saw up here, because we added an element, so we doubled the number of subsets. And I'm not going to list them, they're listed up here. And then 2, 3, 4, we have 3 elements, and now we have 8 subsets, and they're listed up here. Okay? Now, if we have n elements, well, we note that 1 is 2 to the 0, 2 is 2 to the 1, 4 is 2 squared, 8 is 2 cubed, and every time we're doubling the number, so the power of 2 is going to increase by 1 every time, and we're going to have then 2 to the n subsets if we have n elements in a subset. Okay? Again, 2 to the 0 is 2 to the n. If n is a number in the subset. If n is 0, we get 2 to the 0. If n is 1, we get 2 to the 1 subsets. If n is 2, we get 2 to the second subsets. N is 3, we get 2 to the third or 8 subsets. So if n is the number of elements in the subset, since this pattern is going to continue, we have 2 to the n elements, or 2 to the n possible subsets.